Okay, as a math teacher who works with special needs students, sometimes we may have to create alternative ways for students to do things if they don't get the traditional way of solving problems. So, for instance, the traditional algorithm for adding fractions, let's say we have 3/5 plus, I don't know, 2 over 20. The traditional way that this was taught was for students to find a common denominator, which assumes that they understand factors and multiples. And here the common denominator would be 20. And they would need to rewrite both fractions to get to 20. So for them to do that, they would also need to understand that multiplying the numerator and denominator by the same number is essentially multiplying by 1, and that 3/5 is equivalent to 12 over 20. And eventually they get 14 over 20, and then they would also have to simplify to 7 over 10. Now, that's difficult for any student, but if you compound that with, an emotional behavioral disorder or some other type of needs, it becomes very, very difficult for a kid to understand this. An alternative to the traditional method of adding fractions when the denominators are multiples of each other is something called the C method. Okay, and the C method works like this. Let's take the same problem, 3/5 plus 2 over 20. Whoops. And what we will do is we will make a loop that's shaped like the letter C, starting always at the larger number. We will start at the larger number and kind of loop around like that. When we go from 20 to 5, that's our divide step. So 20 divided by 5 will give us 4, obviously. We take that 4 and we multiply it by 3. 4 times 3 gives us 12. 12 plus 2 is 14 over 20, which simplifies to 7 over 10. Now, mathematically, they're equivalent, but for some students, this is easier to see than this. So we'll do that again. We'll look at the C method again, and the C method also works for subtraction problems where the denominators are multiples of each other. So let's take 9 over, let's say 16 minus 1/8, okay? Again, we start at the larger number and loop around and make a C shape. Okay, so again, 16 divided by 8, we get 2. 2 times 1, we multiply. 2 times 1, we get 2, and then we simply do the math. 9 minus 2 is 7 over 16, and in this case, we do not have to simplify. So, we'll look at the C method one more time before ending this particular video. So let's say we have 19 over 30, and we want to subtract 1/3. Start at the large number, loop around. 30 divided by 3 is 10. 10 times 1 is 10. 19 minus 10 is 9 over 30. And the student would still need to simplify and get 3 over 10. Hopefully this has been helpful, and hopefully it's something that you can begin to use in your class with your students who struggle with traditional algorithms for adding and subtracting fractions.